Introduction to functions. In dealing with functions, there's some vocabulary that we need to know. A relation is a point or a set of points or ordered pairs. The domain are the x values in the relation. The range are the y values in the relation. And a function is a relation in which each domain has exactly one range, which means if we have a set of points, the x value cannot be repeated in order for it to be a function. Find the domain and range and tell if it's a function. Well, as I said, the domain are the x values in the function and the range are the y values in the function. So when we look at this set of points or these ordered pairs, or this, which would be a relation, if we are going to list the points in the domain, first of all, we use braces, which are the squiggly brackets. And we don't use parentheses because if there were only two numbers in the domain, if we used parentheses, it would look like an ordered pair. So in order to tell the difference, we use braces around our domain and our range. So the domain are all of our x values, which in this case would be 3, 11, and 5. And then the range are all of the y values. Again, we use the braces or the squiggly brackets. And in this case, it would be -1, 4, and 3. Then it asks if it's a function. Well, if the x values are repeated, then it's not a function. Well, if you'll notice, all the x values are different, so this is a function. All right, let's look at B. Here we have 4 points in our relation. And the domain of these 4 points would be all of the x values. So 5, 1, 3, and -6. And the range are all of the y values, which would be 0, 4, 5, and then we have a 0 again, but we don't need to list it again. When it's asking what points are in the domain or in the range, we've already listed 0, so we don't need to write it again. And this says, is this a function? Well, the y values are repeated, but none of the x values are repeated. So it's okay if there's a y value that's repeated. So this is still a function. Okay, let's look at C. The domain in this set of points or this relation would just be 5 because all of the x values are 5. And the range is 3, 2, 4. Well, since the x value is repeated, this is not a function. D is listed a little differently. It's listed as a t-table, but remember in a t-table, each row is a point. So when we have an x value of 2 and a y value of 6, that's like the point 2, 6. So the domain would just be all of the different x values. So in this case, it would be 2, -5, 0, and we have 2 again, but we've already listed 2, so we don't need to write it again. And then the range is all the y values, so it would be 6, 1, 0, -3. Well, since the x values repeat, this is not a function. When we have the graph of a function, we can determine if it's, when we have the graph of a line or any graph, we can tell if it's a function by whether or not it passes the vertical line test. So we know that a vertical line is a line that does this, it goes straight up and down. And what the vertical line test says is if we take a vertical line and pass it across the graph, If it touches that line in more than one spot at a time, then it's not a function. Well, this first graph does not touch the vertical line in more than one spot at a time, so it is a function. But this second graph, when we get right here, it's touching our vertical line in more than one spot at a time. So this is not a function. So this first one is a function, and the second one is not a function. Now these are separate points on a graph, but sometimes we have lines or circles or parabolas or different things like that. So if we use the vertical line test on a graph like this, we can see that this first graph would not pass the vertical line test because it's touching our vertical line in more than one spot at a time. But the second graph, it would pass the vertical line test. And any line, as long as it's not a vertical line, would be a function. It would pass the vertical line test. So again, this is not a function, and this is a function. Function notation is a way to name an algebraic expression. The most common names that are given to expressions in math are, well, they look like this. This is one. This is another common one. This is another common one. And the way that we read this is not f times x or f parentheses x. This is f of x, g of x, and h of x. That's the way that we read this. So here are some examples of function notation. And the reason that we use function notation is just to be able to tell which function we're talking about. So instead of having to say the whole function, we can just say the f function or the h function, and you'll know which function we're talking about. Now, in this example, we have f of x equals 2x plus 3. F of x is not always going to equal 2x plus 3. Again, it's just a way to name the function. And if you're told to evaluate a function, that just means you're going to plug something into the function. And you'll be given the function, and you'll be told what to plug into the function. So this says evaluate the following functions given the values below. All right, in A, it says to find f of negative 2. So that just tells me we're going to use the f function, and we're going to plug in negative 2 into the function every place we see an x. So let's do that. We're going to plug in negative 2 where the x is. So I have 2, and I'm plugging in negative 2 where the x is, plus 3. Now that f of negative 2, this part of the function, we don't do anything with that. That's just the name. So we're only working with the right side of the function. Okay, so 2 times negative 2, that's negative 4, plus 3, which would be negative 1. So f of negative 2 equals negative 1. Next, B says g of negative 5. So that tells me we're going to use the g function, and we're going to plug in negative 5 where we see the x. Okay, so the g function is x squared. So that means we're going to plug in negative 5 where the x is, and always when you plug things in, put it in parentheses. So we're plugging in negative 5 where the x is, and the x is being squared. So this is negative 5 squared, which would be a positive 25. And that's my answer. In the last example, we're trying to find h of 100. So that means we're going to use the h function and plug in 100 where we see an x. Okay, so we're plugging in 100 where the x is. So we're just taking the square root of 100, and the square root of 100 is 10. And that's how we evaluate a function.